Alright, everybody, welcome back. I just found out that I don't need to crop off the top of the screen. My name happens to be up there when I am in full screen, or in, not full screen. But if I drop it in full screen, you guys don't have to see the little clip on the bottom. So that's good. Um, so what we are looking at here now is my rough design package for the preamp portion of the entire circuit. I'm not sure if I need to bias the microphone circuit at all. That's something that I might need to go back and add in this area over here. If it let me draw. Okay. You might need to add in a biasing circuit right here. Because I know that if the microphone has you can handle the audio to make it negative or make it positive. I remember when we did this in school, we happened to use about 9 volts using a DC battery, and then we offset our microphone to 4.5 volts. So the sinusoidal wave would be centered around 4.5 volts. So that would look something like this, where this is 0. And this would be 4.5. We did something similar to this, where our microphone would look like that. But I don't know. I might be able to do it in this project where it's centered around 0, and we have negative voltage in the circuit, which, looking at this circuit, I don't think this will produce negative voltage. What this is, I believe the instrumental amplifier will only produce positive voltage because it is a differential amplifier. It's just a modified differential amplifier that they swapped some components. The main difference here is they put this 2R1 here, whereas in the single-ended one, they typically only put a ground there, which happens to decrease the quality. My books has a little excerpt about this. Let me grab it so you can see it. Oops. So what it says, so a difference amplifier, I can draw one up for you real quick. It looks similar to this. It will look like this with input 1, input 2 with a resistor in, down to ground. This is ground with an op amp. We'll ignore the terminals and whatnot. So we have input 1, input 2, we have output, we have ground with R1, R2, R3 with a negative and a positive. So you can use superposition to solve this. What you end up getting is that you can solve this if you treat this as ground. You can see that this is an inverting op amp where it's just 3 over 1 is equal to AD. And then I believe that means that you can multiply it with the linearity, law of linearity, which means that you ground this input then. And now you get you get R2 over R1 times VD, which is obviously the input voltage. VID, the difference between the two. So that would be from here to here. So this is kind of what it would look like without the instrumental amplifier. Kind of run into some issues. They say that the issue is that you have a low input resistance right here and right here, low input resistance. Whereas you don't have that in this guy. This guy has infinite due to it being an op amp. And the ideal properties of op amp say that it has an infinite input resistance and it has a 0 output resistance, ideally. in the real world case, it's not so, but we can treat it like so. On top, they also recommend you can use these now because you're using these as voltage followers. These two nodes, now you can amplify your voltage first and then also have an additional stage where you're cascading them slightly. The main goal of these is just to get the infinite input resistance, and then from here you can use the inverting or non-inverting op amp to get them throughout. And this is what I ended up doing. I think this one is going to be slightly better. Right here, you can see I was looking at the equation to get the gain. They give it to me in my book. Luckily, it's very enjoyable to have a book. I did this a long time ago. So they say V output is R4 over R3, 1 plus R2 over R1, which is this whole expression. So I said that I would want this guy. I think I need to alter this slightly. I just realized that I made a slight mistake in my maths because I really would want this to be 1, but since this would be 2, that would make this 2, which would make this 2.5, which is a slight change to what I have done here. I think this is 3.5, so this should be 2.5. If you catch what I'm saying here, this 2 will multiply into here, and this will become a 2. And then I want this to be 2.5, so I subtract this out, so this is going to be 2. If you caught that, glad you caught it. So that is your whole input stage here. Depending, like I said, on how you want to do your input, you can offset it, or you may be able to center it around 0. I've yet to figure this out. I'm still in the building stage. From there, what I'm thinking is that I want roughly, I think 40 gain is a good estimate. I think I'm going to have somewhere in the tens to hundreds of millivolts. So if I have a 40 gain, that will put me about maybe 4 volts, give or take. Maybe I'm thinking down here, I was thinking about it, maybe it will put me around a volt in the volt range. And at that point, I'd like to see if I can do some sort of clamp circuit to add distortion. So I figure that there's only 2 good spots to put the distortion. You have the first spot, which is where I chose, or you have a preamplifier. The problem with the preamplifier is that you're going to have to... There's common distortion that is being filtered out by the circuit, but you may not be able to do that before the circuit and have a good result, because then you might not get such a difference anymore because you're clamping the circuit, and it can cause other issues that I might not think about. But the options are before and after. Once you get up to this stage, this is just a summer. This summer is, I'm hoping for about a 4x gain here, which will put me from 10x to 40x into the power amp 40x on, let's say 50 millivolts, or 100 millivolts will put me at 4 volts. That's why I was a little bit lower down here, 10 volts, 100 millivolts to 1 volt. I was thinking 4 volts, I think, is a decent starting point. I'd like to get about, give or take, 4 amps out of the entire circuit. So my goal is to have at least 200 watts, which I believe we looked at this up here. 200 watts equals V times I, assuming that I have 100 volts. So if I have 4 volts here, I only need to multiply it by 25 times in the power amp, which I think is reasonable. So 25 times, and then I would only need to have two amps. If I get it to 100, 2 amps times this, bam, gets me there. Or maybe if I want, I'm gonna have a little bit of overhead on my current. I'm over-speccing all my diodes just so that I can have the chance maybe I can get this up to 4 amps. So up to 400 watts perhaps. So the next goal is picking where your potentiometers are going to go. So I might not have exactly what I'm going to do yet, but I believe this would be a voltage drop across a diode, and I somehow need to come up with a way to get a positive VC, which is about 1 to 2 volts to add some clipping. So maybe there's some other way to do this. I heard something about germanium diodes or Shockley diodes, which I may need to look into here. This will control the distortion. My thought is I can amplify the distortion or amplify my input signal to clip at these diodes with the potentiometer. If I think of my values well enough that I get to the point where I can get my wave. So essentially I want my wave, I can control the amplitude of my wave here with this potentiometer. And if I make it larger, it's more like it's clipping more and more. So it will be clipped off a lot more. But if I were to make it very small, you could see where I'd have a lot of precision that I'd be losing to the clipping. So that's my original thought, is to put it here. And then obviously once I get them out, take this summer to this summer. If you don't know the summers, very easy. If you make them the same, you're going to have a 1-to-1. So if I make this one 1 and I make this one 1, bam, I get an output of 1-to-1 between these two signals. And you can treat them just like an inverting op amp where it's R2 over R1. So it's this one over this one, or this one over this one. The kind of general idea here is that I'm going to have a series set where this will be a potentiometer, and then this will be a current limiting resistor somewhere. I'll match these two. So maybe they'll be 50 ohms, 100 ohms, 200 ohms, but they'll be the same value. And I'm assuming a 5K. I'm going to probably put a 5K or a 10K pot. 100K pots don't work very well with op amps. 50K perhaps might work a little bit better. But your end solution will be R2 over R1. So the potentiometer, as you increase the resistance of R1, your AD will go down. So this will be your gain. Your gain will go down as you make this potentiometer bigger and bigger in value. So that will give you the option of increasing your microphone volume versus decreasing the volume of the other one. You'll have complete control over what you want there. And as long as you get some sort of gain from the starting stage to the output stage, you'll have some sort of output. I was thinking, I believe the equation is 20 log. 20 log something, and let me pull it up real quick. So it is called power to dB. dB is 10 log P2 over P1. Doubling in the power translates to a direct power ratio dB. Power gain is equal to 20. n log 10. So they for power it's 10, which I accidentally made the mistake of. And this one's supposed to be P2 or P1, which is this is supposed to be the ratio of your input to your output. So I would not know what my ratio of my input to my output is yet. I mean, I think it's going to be something along the lines of 10 millivolts. 10 millivolts over hopefully 200. I mean, this is going to be, you know, I think 2,200 dB, 2,000 dB, which this looks a little wrong to me. I'm hoping to get somewhere 40 dB sounds decent. Somewhere around 100 dB, I believe, is where I'm looking to go. If you happen to know what I did wrong there, let me know in the comments. That'd be cool. This was us talking about the difference amplifier. So the next stage will be running this out to the power amp, and I'll have to design the power amp. I'm assuming BJTs are going to be in here. Looking back here, we might need to ground some of these because there is a ground receptacle on both the XLRs, which will be the input here. This will be an XLR, and then this will be a quarter jack. If you didn't know, quarter jacks are pretty simple. So you have, sometimes you'll have 3. So we'll have signal 1. We'll have signal 2. And then we'll have signal 3. So where signal 3, and then we'll have the option of wire strain support here. So signal 1 and signal 2 are usually plus and minus signals. So this will be just for simplicity, it's plus and minus. The way that it works is that your wave will look like this when you're looking at the difference between these two. So you'll get the sine wave out of here, and this will come out, and then this will be your grounding. This will be chassis ground. For this amplifier, I don't believe you need to ground the chassis because you don't care about where they're starting at. You're just worried about the difference. So that's the good thing about this, is that it will reject common mode input. So if I have an AC signal going onto both of these lines, they will both go into here and they'll end up canceling each other out, which means that you'll just get the difference. So I'm pretty sure you want to, it's either you want to hook up both of these wires up or you want to ground one of these wires, because this will definitely make a difference. If you know, you know. So let me know. So if you have any ideas, I'd like to know anything about the clipping diodes. If you have any ideas on those, the grounding on the instrument / microphone. If you need to offset to half of VDD. Oh, and then one more. I didn't talk about this last time, but this circuit will have to have some sort of DC converter. So I'll be getting 100 volts out of here. I will probably have to step this down at some point to get hopefully something along the lines of 30 volts. Just because these op amps, these rails on these op amps down here only are like plus 36 volts to 0 volts. So I have to somehow get the range for one of these op amps. So I'll have to do that over here. But thanks for watching. If you guys have any comments, leave them down below. I'll try to keep posting semi-recently. I do work, so that's fun. I am enjoying this though. If you guys want to see in the future though, I want to learn how to do Blender. So if you're interested, let me know. And if you guys have any good tutorials for me to watch, leave them in the comments. Thank you.